Okay, here's your problem, and I didn't tell you what order to integrate by, so you can choose. Although I don't really know that it matters, since it looks like it's pretty much the same strategy either way, straight out the gate.
It's like it's not like there's a speech. You got to the use of thing. No. It's why the axles are constants. So it's just. What's up the train? It's all the way. This is still working. See, I use
So maybe get some of you started if you get stuck. Maybe do something like this. Open your eyes. Although I think I'm not going to do y equals 0 to 1. I think I'm going to segue to the next topic by doing when y equals 0, u equals x squared plus 1. And when y equals 1, u equals x squared plus 2.
Yeah, that's the part that makes it horrible.
But either approach works. Good morning, Trent. I still giggle every once in a while when Trent accidentally turned his camera on and fell back asleep. Didn't know that he was on the camera. That shit was funny.
That's funny and weird.
Thank God you were decent. That's all I got to say.
Oh, that's what people do Twitch streams. People do Twitch streams where they sleep and the people like be able to pull whatever speed like people sleep streams that people like delay and like I had to go over it, but like they so they get Alexa and they said Alexa where am I? And then they gave everyone their location, so we had to move. Like when he woke up, he was like,
Are you guys done with this already? I don't want to sit around waiting if you guys are chit-chatting. So if we go up a power, you're the 1/2. And then multiply by the reciprocal, or divide by 1/2 would be multiplied by 2. I got the 1/2 and the 2 out front will cancel. We got 0 to 1, so xu to the 1/2, x squared plus 1 to x squared plus 2 dx.
I don't think I put this right.
I'm going to break this up into 2 integrals.
X in this
It's a minus.
into the BU. Oh, I forgot about that one.
So we have 1/2 the integral from 2 to 3 of u to the 1/2 du minus 1/2 the integral from 1 to 2 of b to the 1/2 dv. In both cases, we're at 3/2. So we're multiplying by the reciprocal.
Oh yeah, I didn't integrate it from the front.
So we all got a 1/3 here, right? Put a 1/3 out front. I got 3 to the 3/2. I think 1.5 is a little bit easier to write. Minus 2 to the 1.5. And then I've got minus another 2 to the 1.5. Plus 1.
What?
Well, 1 to the 1.5, but I mean, still 1. Remember, this minus is going to apply to everything in there. So it's just going to change the signs of these.
No, I'm not looking for this.
Look you back in, so how did he get, how did he not get why, why is it that? Answer is integral to
We changed
R.
Yeah, okay. You gotta look at that keyword. Okay. Okay, so if you want me to take a picture and send it to you.
Not the
then-
prettiest answer, but it's an answer.
I know there's another, I messed up on region, the R. Okay.
And I trust that you know what it means when it's saying type 1 and type 2 intervals.
Yeah.
Okay. Then I
Thank you.
but you spoke that.
Change this down. I don't know how we, how we did that though.
Where all that x equals b equals, that's him changing his bound. So it's underneath the integral, so the x equals 0, u equals 2, x equals 1.
Where
It's just computing the value at the new bound or at the new u value.
Here, I'm taking these values and plugging them in here. To get those.
All before that though. I guess he didn't, I don't know. It's the same thing. I don't know how you got x squared plus 2.
So the same, I did the same thing above. When I had y equals 0, I plugged it in here and y equals 1 as well. And that's how I get those results. When y is 0, this just goes away. U equals x squared plus 1. So that's my new limit of integration. Y equals 1, x squared plus 1 is x squared plus 2. Which is hopefully how you learned how to do it in Calc 1 when you did a U sub and changed the limits of integration. Hopefully.
you something.
I don't know what that Mr. Blakely teacher
No, substance.
hit or miss whether he does a good job, right, James?
I'm just confused. Like, I remember what you're, I know what you're talking about, but I don't.
Oh, you mean the taking derivative?
They put 2, but when there's 2, it's like.
Well, to like going this far with the U subs, you don't. The basics of the U sub is taught one, pretty sure. Isn't it? I don't know. Hey, Mr. Jones, are
Yeah.
U subs taught in Calc 1 or Calc 2? Aren't they taught in
They're
Calc
taught
1?
in Calc 1.
Yeah.
It is one of the first tools. It's how you, when you learn, after you learn all the basic shit in calculus, you got to learn how to deal with weird
Yeah, 'cause-
situations. It had to have been Calc 1.
Yeah, because you have to learn. That's how you learn chain rule.
Yeah. Yeah, it's part of
Yeah.
chain rule.
Yeah, that's how you learn chain rule.
Now, you may not have paid much attention, especially if it was an online class, but
Well, I took
No,
AP
it's
Calculus
not.
AP, so I was still in person for that at least.
I wish my power would quit flickering. If I cut out, I don't know why it's flickering. All right, we got another fun one.
Well, you know what I say.
That's weird. I don't know why that would.
And I recommend if you want, well, go ahead and do it, but then I want to talk about changing. Yeah, let's just do it and then we'll go about changing to the other format. Because it's something we need to practice and get used to doing. This is a pretty easy one to do, but they're not always easy.
Yeah, I can tell.
You know, this is probably not bothering you, but it's kind of bothering me. I think your mouse is over your files. So you or it's just
Click somewhere.
Done.
click somewhere. There we go.
God damn
She's over on purpose. Get over the time.
Hey, open up that Visual Studio and let's see if your code is as bad as John says it is.
Really?
Okay.
Are we talking about John Redden?
Well, who else?
Oh,
is-
well, yeah.
Is
Actually,
Mr. Redden talking shit?
You guys had that friendly rivalry going on. You talk shit about him here, you talk shit about you there.
Nah. Mr. Redden's a good instructor. He just is he likes to wing it. And I don't know if it's deliberate, or at least he likes to make it look like he's winging it. Sometimes I think there's a method to his madness, but often it just looks like madness.
Yeah, sometimes it's hard to tell if he makes mistakes on purpose or on accident.
Usually mistakes are accidents. But every once in a while, like in his, at least computer science, I watch him and he'd be doing something and he'd setting up for something for a future lesson.
Well, no, yeah, and I've noticed that. I've noticed that he'll make a certain mistake on purpose, knowing that it's good learning opportunity. But a lot of the time, it just seems like he'll like do something on accident. It's like, okay, and then just act like it's all planned and say, all right, what did I do wrong?
Right.
Which makes for a good teaching method when it comes to computer science, where it's easy to make the small mistakes.
But even when he's not making mistakes, he'll just show up and go like, all right, what are we doing today? Let's do this. And he'll start doing something. And the way he says it, it makes it sound like he had no preparation going on whatsoever. But the present lecture is a segue to something we're going to do later on. And so like he is prepping, but he's acting like he isn't.
Are you saying he's like, there's a word for this. Is he gaslighting us by saying that he's not, by acting like he's not prepping?
I don't know that gaslighting is the right word. Gaslighting is tend to use for negative shit. So if you tried to integrate y here, you're wrong. Dx is first.
Oh, yeah.
You're wrong.
Yeah.
Let's just make sure you're not. So in terms of x, there is no x. So this just becomes x evaluated from y to 3 minus y dy. Important to note.
Forgot the y at xy. XY.
Stop learning from reading.
Oh yeah, there's a xy. You're right. There's a y in there.
It's a good thing you can hear us this time.
Even though this function that we're looking at is just y, we could write this as a function g of x, h of y. But so it would look like it's a product and we could separate it into two integrals, but we can't because the limits of integration. When you have variables in the limits of integration, you cannot separate. Okay. Just wanted to point that out here. So what do we got? 1 to the 3 halves. We got 3y minus y squared, and then minus another y squared.
The other way square? You're just plugging in that.
Yeah, you're just plugging in the limits of integration. square.
So
0 or
you put
2 y.
exponents, a y-axis.
You forgot the squared on 3 halves y.
Just seeing if you're paying attention.
Hell, man.
You're starting to sound like Mr. Redden.
All right.
No, that was a legit mistake. Mr. Redden likes to play it off like he it was deliberate. I think it's more important that students see that teachers fuck up too. You know, we're human. We don't know everything. And when we do know everything, we still make human mistakes. We're not like Ben. We're not a robot.
Okay. Oh.
Oh, yeah.
So I got 3 halves cubed
Oh, we need to make more robots.
minus, look at this, 2/3 times 3 halves cubed. And then I got minus 3 halves minus 2/3.
Oh,
There's a lot of shit going on here, right?
and
So we got 27/8 minus. This simplifies. I can cancel out a 2/3 and a 3 half, and just this boils down to 3 halves squared. So 27/8 minus 9/4 minus, what do we got here? Get a common denominator. I've got 9/6 minus 4/6, so 5/6.
the second part piece where you just simplified it.
So this would clean up to 9/8 minus 5/6. So we need another common denominator. The lowest common denominator would be 24. Although 8 times 6 is easier to recognize. 24 is the lowest. So you got 27 minus 20, or 7/24. Assuming I didn't make any mistakes. And we've already seen that I do make mistakes, so. Did anyone else get that?
I got that. I like what you did with the, I use my calculator though. I like what you did with the 2/3 and the, with multiplied by the 3/2 cube.
Clean that up a little bit, yeah. Makes it a little easier, right?
By it and then. Hey, but I didn't put the fraction question for no reason.
Oh, look at that. I did all that fraction work without a calculator too. Don't be lazy. Practice doing fractions.
I was like, what is this? I specifically found one that had.
You know what? I don't even blame you because I think I basically did the same thing.
That's
If
really
you
the only way-
practice enough, you don't need a calculator to do basic fraction.
You have your any little thing where you can check your, make stuff definite, check your answer. So sometimes you like.
I don't tend to use it because
Freezes.
it will tend to just give you a really ridiculous decimal that you can't really use very well.
Oh, well, if you, I mean, it's not like it's just a check, it's like when check, right?
Yeah.
But I mean, you use the decimal or you write that down and then you do your integral and then at the end you
Yeah.
evaluate it, you get the same decimal, then you probably get it right. As long as you don't use the same.
We're gonna do the same problem, but we're gonna switch to doing dy dx,
That part.
okay?
If you were allowed to use a graphic calculator.
It's not a graphic out there.
Oh, it's not.
It's a graph off.
Yes. Eric,
That's just. No, that's playing the system right there. I'm good.
all right. So if we want to switch to doing dy dx to change the order,
Like, it wouldn't help.
this is not as simple as just changing the order of integration. Since we have variables in there, we can't just change the order. What we need to do is we need to draw a picture. So let's figure out what's going on. We've got from 1 to 3 halves, or 1.5 along x.
Yeah, see what you're doing.
Oh, yeah, you're gonna have to bring the whiteboard up.
Now the other integral had y and 3 minus y. So this is x. So we've got a line y equals x. Wow, maybe I should space this a little bit better so it looks right. There we go.
8 times 3 is 24.
I'm gonna need more room. Let's see. I need to be able to go up to 3. Okay, so 1 to 1.5 is our x range. And then we've got y equals x is like this.
That's 18. 27 times 18 is 27.
Yeah,
minus
make that a little bit tighter.
7 plus 2 is 7. 9. 8 by 9. I don't know. I just give it. I break it up in like this, and like I get closer to the number, and then I add.
And x equals 3 minus y is the same thing as y equals 3 minus x,
That's what we're saying.
which means we are going downhill.
You just-
That's how you get supposed to plug God. One part. But ask you, they give you one.
So we are doing this range. Do they cross at 1.5? It looks like it. We said the two x's equal to each other. Y equals 3 minus y. 2y equals 3 halves. Yes, they do cross at y equals 1.5. So this is what we're looking at here. We did do x or 1 to 1.5. Now we want to do x in terms of y. So if we want to switch this in, so this is what we're looking at right here. Everyone with me right there? Now we did the dy or dx first, which means little slivers of x. We did the little slivers of x and then we integrated along y. So now if we change it up, y is our outside answer or outside integral. So let's take a look at what happens. We're going from, we know this crosses at 1.5. So y is going from, that was already dy. I already knew that. I need to do dx. I said that shit all wrong. But it was still ended up being right. It looks like y has got the same. No, y is going from 0 to 1.5. What am I doing here?
Scan all.
I confused myself. Let me hold on. Wait a second.
That new stuff.
That's right now, I think.
No, this is not what we had. dy. So y was going from 1 to 3 halves. That's how it was initially. So we were only doing this section right here. That ain't right.
How do we plug in numbers in or stuff?
That half. There we go. That's got both. It's between y and 3 minus. There we go. There we go. This makes much more sense. Between y and 3 minus y, and then x. All right, so we were going this way, y to that way. Now if we go the other way, we're going that direction, and we got to break it up into 2 parts. I don't know that I want to do this. This is kind of ugly. We've got from x going from 1 to 1.5. Y equals, y goes from x to 1.5. And then when we go from when x goes from 1.5 to 2, we're going from y is going from 1.5 up to 3 minus x. So if we shifted the way we did the order of integration, this really fucks this problem up. This makes it terrible. What we would have,
Like two set of rows.
we're doing dx on the outside. We got 1.5, 1 to 1.5, x to 1.5, y dy dx, plus 1.5 to 2, 1.5 to 3 minus x, y dy dx. So maybe changing order of integration here is not a good idea, but it's always worth checking out if the problem is not easy to do.
These are the types of problems that are really good to draw out, because this could determine how much work you actually end up putting into your area and volume intervals. Well, that's just kind of your problem. You should
Yeah, the business.
learn to draw graphs better.
By extensive graph.
And we can see, looking at this triangle, that we're gonna have two shitty regions. When we went upwards first, we're just going from one line to the next, not a problem. When we go the other way, this side has a different integral than that side. So drawing a picture of what it looks like can often help you set up how you want to do your limits of integration.
And along the dead one.
Especially if you don't like the first way the problem looks set up.
No, we like
Here
ours.
it was set up pretty good.
They have that.
The very first integral was pretty easy to do, but if it's not easy to do, you gotta be able to look at it, and pull it apart and go, what should I do?
Like a standalone half the dead one.
Wait, what was that? Like an iPhone app. Well, but a calculator? I wouldn't just don't expect to be allowed on the test.
So in light of that, let's do another one both ways.
I don't know.
And I wouldn't expect to have the processing power.
Or no graph.
Let's look at this one and do it both ways.
DDR format. What? I heard something.
What, Lawrence?
The new FNL project. So Windows on a calculator.
You can do that.
Benjamin, do you want to do that? Install Windows on a calculator.
Install Windows on the internet
Well, if you can install Windows on a calculator, I'm just not gonna start, I'm gonna stop allowing calculators in classes. So I'm gonna pretend I didn't fucking hear that.
Wait, stop relying all calculators? Like,
Yes. Because, well, no, not all calculators, but anything that's not trivial. A basic scientific calculator.
Where's your division button?
wait, put that calculator back up. That calculator back up? What was that? What was that? There's no fucking division button.
There is a division button.
I guess I gotta get it.
There's just no fraction button.
Yeah, sometime.
Oh. Yeah, fraction buttons are very important.
Do you, what? You lazy. Ah.
Hey,
You're lucky your student.
I'll do fractions in my head sometimes, but like sometimes I just need to like find that, like calculate the fraction. Put it on the calculator. It's just too much.
What do you need a fraction button for? Like shifting from a decimal to a fraction?
No, going from like
It automatically-
subtracting fractions or adding fractions or like
That's just
like-
being lazy as fuck.
Well, like
That's
actually,
super lazy.
well, maybe not multiply fractions, but like dividing.
Dividing fractions, you could do that. We're like water, you know, we take the easiest path.
Okay, well, I'll still do some stuff in my head because it's good to practice your mental math. But I'll still do some fractions in my calculator.
I don't do very many fractions in my head. I don't like doing multiplication or division of fractions in my head. You know, it often leads to mistakes. I will write that shit
And I
down,
won't
but it is
rely
not
on
hard to do. In fact, I think you make yourself dumber when you use a calculator to do it because you're deliberately trying to not use your brain to do something you know how to do and you've known how to do for a long time. And it's a good skill.
Yeah, I'll still practice my mental math, but I might use my calculator to check myself. Or if I
That's totally different now. That's a totally different statement.
well, you already missed the second part. I said, or if I'm lazy. No, I certainly won't be like some of the Algebra 1 students I knew when I was a freshman, where my teacher was getting really pissed at them because they were still putting in calculator 5 times 1.
What? You never know.
Some of you need to still do that.
You never fucking know. You never know.
What I mean?
So,
Hold on, that's not right.
4 times 1 is
X equals 0. Read your fucking limits there, Dave.
hopefully.
Put my x-axis back down. And now we're going from y equals 1 to y equals 2.
Well, he's writing the interval separately.
Oh no, never mind. Scratch that.
so right now it's set up so that we could do dy dx. I don't
You could do it
I think
both
the
ways.
y dx is the easiest
One of
setup.
them- But one will just be more messy.
Right, but the way he gave us the intervals without drawing a picture, how is that set up to do?
You should be doing dx dy really. Shouldn't you be doing dx dy first? Do dy dx will just be messier because you'll have 2 sets.
What is that, Amy? That's just areas. That's just the differential of the areas.
We want to integrate from 0 to y first, which would be the dx. That's the easiest method.
Oh, this is try.
Oh. Yeah.
So you can't just flip those around, right?
For what? What do you mean?
dy
No,
dx.
because notice if we go the other way, we got 2 regions.
That's where my confusion kind of like I don't.
So we're gonna let's look at doing the write-up for both. That's probably the better thing to start with, because doing the integral isn't that bad once you got it set up. So this was the basic setup. We're going dx first. So we're doing little layers. We're finding little x slices, and then we're going to integrate along y. When we go the other way, it breaks it up into 2 regions. So we're doing dy dx. So what happens with dy? Well, from x equals 0 to 1, y is just going from 1 to 2. But then when x is going from 1 to 2, right here, y is going from x to 2. So our integrals would be, we're doing dy first, which means dx is on the outside. We'd have 0 to 1, 1 to 2, xy squared dy dx. plus 1 to 2 x to 2 xy squared dy dx.
Did you put are the differentials supposed to be in the same order?
Yes. This is doing it one way, doing it the other way has two integrals,
Oh,
which that's what we were just talking about. This is integral 1. Why is that not showing up well? Let's try that again. A to B. And unless you draw a picture, you are not going to get that shit out of it.
Look at the picture. I don't know.
Y equals X. Why not we are using Y for 1?
I don't know the
and Y
brand
for X? How do you determine that?
By the region encapsulated, what we originally had, 0 to Y. This is gives us Y equals an X line and X equals 0 line. So we're doing like this part here says we are somewhere in this region. And then the 1 to 2 traps it right here for the y equals 1 to 2, traps that region right there. That tells us we have that region. If we go from this direction to that direction first, it looks pretty clear. There's no different gap. Going from y equals 1 to y equals 2, I can go from x equals 0 to x equals y the whole way. That's our first setup up here.
Okay.
So maybe I'll draw that picture a little bit bigger. So that's 2, that's 1. This is the y equals x line.
Okay.
So we did that one, but now if we want to go upwards, we can see that as we go up, where we start from changes after we get to x equals 1. So this shows me I have to break up my integral from 0 to 1. I'll do that as one part, and then 1 to 2, that is the other part. So I'm going to put a little line in there and take a look at it and go, okay, what's happening here? Rectangular region is pretty easy. 0 is less than or equal to x, less than or equal to 1. 1 is less than or equal to y, less than or equal to 2. When I get to the other one, we're still going along x's. So I know what this has got to be 1 is less than or equal to x, less than or equal to 2. I got to do this in terms of y, and I'm going upwards. Where did I start? I started at the y equals x line. So that's my lower boundary. My upper boundary is the y equals 2 line.
Oh, okay. So like
We go from here to here.
Gotcha.
Then you-
Does that make sense?
Going
Makes
like
sense.
this weird shape.
Perfect.
I think you like cut it in half. Or he like did this. This is easy to find, area this. And then he just did area that and that. I think that's how you can
So let's figure out what the problem is.
link two intervals.
If I integrate that with respect to x first,
If you just do like that. It's like. And it's like. Well, that's a student rate. Why do the weird shape like this? All they have to go. Other than pieces.
so pulling what you need from the picture and stuff like that, that the limits were the hardest thing in this problem. So they're good to practice on homework and shit like that. even on problems that don't tell you to do it both ways, at least try to set it up both ways. That way you get practice switching figuring out how the region should look. That would be my pro tip, because the actual integration isn't that challenging once you get doing it. It's the setup of the problems, the hardest thing here. Which means when we do the test, guess what part you're going to have to do as well as doing the integration? You're going to have to set up the picture. That's not this week, though. Chapter 14 tests is in the future.
I'm worried now.
That's the last. That's the final.
And it's 8:55, so there's not time to really do another one. So we'll do more tomorrow. But we're going to continue 14.2 tomorrow because it's the harder section of 14.1 and 14.2. Most of today we've been looking at 14.2 problems. We'll continue that tomorrow.
It's 15 is hard. I take it off. I take that 0 on Monday. Let's get better about.
Are you openly saying that you're gonna take a 0 on one of the tests?
I know. Take the 0 on the next one. You really want to play with the next. Yeah. Take a 0.
If you take a 0 on a test because you did well on the rest of the test, don't ask me for a letter of recommendation. I'll tell you that right now. I don't approve.
Jones, you know my ego won't let me take a 0 on a test.
Nobody would accept it.
I'll see you guys tomorrow.
You see your phone on you?
Yeah. It's only 7 hours. It didn't take that long. It'd be like 15 minutes.
You for it.
No. No. I didn't do all the read.
Oh, yeah, the first part of it is easy, and the second part is what's kind of.
All right, there doesn't seem to be any questions, so I'll go ahead and sign off.
Okay.
Clear.
See you guys.